I was here actually for the last presentation, and there was a bit of chuckling when the title of our presentation was mentioned. It sounded more like an abstract than a title. So we thought, well, if we were going to put this into language that might be better, if we were not trying to present at an academic conference, but to you all, what might be a clearer way of saying what we do? And what we do is we engineer smart cities. We're from the School of Civil and Environmental Engineering. We consider many factors, human factors, other things, but we're very interested in concepts related to engineering smart cities. Yes?
I can't hear you when that air came on.
Yeah, speak up.
Okay. I got that. Okay, so you can think of our title of our presentation today as Engineering Smart Cities. I think that more or less covers it. But since we did have the very professor-like title, I thought, why not give you a little insight into something that we do just briefly as a intro. And so just a few weeks ago, we organized a Envisioning the Future City workshop, a National Science Foundation funded research workshop where we brought in smart cities faculty from around the world to come in and talk about the future. And we were inspired to do that by this effort by Isaac Asimov. Many of you know him as an author. He was also a professor of biochemistry. And he, at one point, came into contact with these postcards that were created in 1899 to be released in the 1900 World's Fair or something of that ilk in Paris, where people envisioned what would the future be like in 100 years. And so he wrote a book, and he talks in that book about how good of a job did they do envisioning the future life in 100 years. And so we'll come back to that in the end. This is the group of faculty that were part of this Smart Cities workshop, all hoping that you will live long and prosper. But one of the nice things about that workshop was a lot of the things that came out as the important things we need to be doing now in order to enable the smart city of the future are the things that we saw when we looked at the Smart Atlanta website, and also things that we're working on in our lab. So we're going to try and tell you our story from the language of the Smart Atlanta website. First, some introduction, kind of how did we get to smart cities, so just a few minutes background on us. And then we're going to talk about our current efforts in the lab, and we're going to do that for each of the 5 pillars or each of the 5 objectives that are listed on the Smart Atlanta website. What are things that we're doing now to address those in our research and pedagogy and outreach? And then finally, what are some new developments in our lab that we think tie really nicely with the strategies that are listed on the Smart Atlanta website? And so hopefully it'll be a little bit clearer than the original Professor Speak title. So just quickly, first, by way of introduction. I started this laboratory 10, 12 years ago. I had some industrial experience as well. So like many professors, I wanted to examine, like a lot of engineering professors, wanted to model things. But we were also interested in how we can impact, how we can kind of make a difference. And so the lab's mission is not just to examine and model, but improve the kind of big changes that are happening in engineered networks. So civil engineering, but other engineering as well, typically at the interface between human networks and engineered networks. And we want to do those on topics that are either industrially very important or societally very relevant. So we started 12 years ago, the big problem at the time, how do we get lots of masses of information into building information models? So the city collects a lot of these models for new buildings that are built, new structures of any type. Well, there was a big challenge to think about how do we move from this pretty picture of a building you see here in 3D, how do we move from a pretty representation to an intelligent model? And so we did a lot of work on how do we get data, how do we get information into these kinds of models. Moving forward in time a little bit, if you remember 10 years ago, there was a lot of consternation societally about offshore outsourcing. There's been a lot of return of manufacturing to the United States. But this was a big societal issue, and so we did a couple of very applied projects to help companies, organizations figure out how they can work together better in an international context. These are 2 tools we developed in collaboration with the Construction Industry Institute to help U.S. companies that want to work abroad to do a better job of not just getting more revenues, but also keeping the profitability at pace. The third area, which kind of culminates the 2 together, is we thought, well, if there is this global cross-cultural collaboration that needs to be done, and we can get the information into these virtual models, what if we virtualize the process? What if we put people, these are avatars, together with those BIM models and have them collaborate across country borders to actually make these buildings more energy efficient and so on. And this is a list of or logos of the various universities that are involved in that. We run it, with Georgia Tech's in the center, but there's the Indian Institute of Technology, so we've got universities from India, from Finland, from the Netherlands, and from Turkey, thank you, among others in the United States. The fourth, or only five, area where we got excited was in the area of energy efficiency. So you collect these BIM models, the city collects these BIM models. Well, very often these are CD-ROMs that end up sitting on a shelf. So how can we make these models actually useful during the operational stage of a building? And so we developed tools that can take the masses of data we can collect on energy use in a building and use the building information model to actually put that information in front of occupants and see if we can get them to reduce their energy consumption as a result of that feedback. And then the final area we've been working in the past that builds us up to present is in resilience in cities, in particular in response to natural disasters. And so we started studying this with Hurricane Sandy in 2012, where we looked at how people's movement patterns changed during the hurricane as compared to before, and then how those movement patterns kind of how long it took for those movement patterns to come back to steady state after the hurricane. And so all of this sort of sets the stage for the smart cities work that we're doing. So if we take this in the middle, the idea of putting lots of information into a model, we've expanded that concept to the whole city. And so we built a complete digital representation of the city of Atlanta. And so that's part of it. The other part of it is getting people in there. And so you'll hear in our current efforts about how we're trying to engage citizens with this virtual model of the city of Atlanta. The two key areas of research for us as we use that are urban sustainability, a lot of electricity, but also water consumption, other types of resource efficiencies, and urban resilience. And so we'll talk about a grant we just found out we received this week in this area. And then lastly, how does the global fit in? We have created the virtual version of Atlanta. We call it Atlanta, @Atlanta, which we think is cool. We're nerds. But in any case, that's Atlanta. How does this scale when we talk about other cities in the United States? Those professors that came together for that workshop were from all over the world. And so how can we take what we learn, what we develop here in Atlanta, and make it meaningful in other cities? And so, as I said, we're going to try and tell you our story using the Smart Atlanta objectives. There are 5 of those objectives on the website. We're going to talk about mobility, how our research is touching on that objective or that pillar. Public safety, environmental sustainability, city operational efficiency, and public and business engagement. And so Nada's going to carry you through the first.
Mobility. In terms of mobility, smart cities get a lot of attention these days. There are lots of great researchers that do work in transportation area, mainly because optimizing transportation in the city is a huge problem. We in our lab looked at mobility in terms of looking at locations of individuals, regardless of the mode of transportation that they take during the day. Here I would like to show you a case in Chicago that we studied earlier, and we were interested to see how does that correlate or relate to the energy consumption in the city. So on the top you will see those blue dots that are blinking. They're all locations of people all the time. So over the course of a day, they will be very congested during the normal hours of the day, and then when it gets to the later hours of the day, it will fade out. And then on the right, you would see the distribution of these mobility patterns for 2 different populations. We were interested to look at returners and explorers, and by that I mean returners are those populations who have a more predictive mobility pattern, like people who just go to work and come back home, and that repeats every day. And then explorers are the ones who are more adventurous. They go to other locations in the city, or they're tourists. So their mobility pattern is not that predictive. And then we were interested to see how does that correlate with energy consumption in buildings. So on the left, you would see the distribution of the energy use across around like 800 census tracts on the city. And this changes obviously over time. And on the left, you'll see the distribution of those energy consumptions for residential and commercial buildings. And then the red locations, the darker locations, are obviously the hotspots of energy consumption. And we were interested to see if there is a relationship, and found out that yes, different populations correlate differently with different building types. In this case, we found that returners strongly correlate with energy consumption in residential buildings. And then we were interested also to look at how that mobility pattern in Atlanta correlates with infrastructure development. So we looked at a few neighborhoods, 4 neighborhoods, mainly around Midtown area. And then we were interested to see whether the central mass of the mobility of the people changes over year as a result. And we looked at 2014 and 2016. And then we saw, interestingly, that the center of mass shifted towards the north a little bit over those 2 years. And then we looked at the neighborhoods and see what are the infrastructure development, or what are the main changes that happened. One of the big things that we noticed was the Beltline had a lot of development in those neighborhoods, and that increased obviously a lot of movement pattern that has enabled a lot of walking and biking, so that has changed in the mobility in that area.
Very good. So I wanted to also share for the second pillar on public safety our take. And so this picture here on the right was not an unfamiliar scene after Hurricane Harvey, even though it was quite diminished by the time it got here. This was right in front of my house. So the tree fell over the power line, snapped it. It was sparking. It never caught fully on fire, but it certainly generated a lot of smoke and a lot of concern amongst the neighbor, especially with a bunch of little kids running around and a live power cable on the ground out there for what ended up being 4 days. But on the left-hand side here are social media postings and their reference points. And so we proposed to the National Science Foundation, and this is the grant I said we just found out we will receive this week, was to take a look at these and do an analysis of the sentiment, so just how upset are people, and the geographical clustering in space and time to identify in a bigger emergency like a hurricane, where are the smaller crises that need to be addressed? Because first responders in Hurricane Harvey were overloaded, and so there's a need to find how to deploy them as efficiently as possible. So we're developing this system now that would allow you, one, to identify, track, and interactively visualize these kinds of things during a larger scale natural disaster.
In terms of environmental sustainability, one of our biggest focus was in through a course that we were offering in the spring semester at Georgia Tech. So the course was not just Georgia Tech, as JT briefly mentioned earlier. It's in collaboration with a few other universities. This semester was with University of Boğaziçi in Turkey. It was with Washington State University and Virginia Tech. So the way it works is we have a virtual version of Atlanta, and students were not meeting in person. They were all teaming up with their other students in those universities, and then they were meeting in that virtual environment as avatars, as you could see on the right. And their case study, well, the final project was to work on the retrofit proposal for the Biltmore building. Some of you may be familiar with the Biltmore in Tech Square, so that's recently purchased by Georgia Tech, and they were interested to reduce the carbon emission of the building and retrofit the building. And we went to the building. We took our Georgia Tech as experts for the subject matter. We took them to the building, and they talked to the engineers and came up with ideas, and then they collaborated with other civil engineering expert areas in other universities within that virtual environment, which the reason for that is that enabled them to create that building virtually and walk through the building and share it with the students from other universities and design it and retrofit it and see how it changes across the neighborhood. And here on the right you see they're presenting their research for the final project presentation, and then so you see the solar panels that came up on the roof for the building. So that way we're trying to encourage the students to think in terms of city and sustainability.
One other area that we're working in environmental sustainability we want to mention, just because it is such a big deal at Georgia Tech, is the living building. And hopefully many of you have heard about this building. It'll be the most sustainable building ever built in the South. And so we're doing some human-computer interaction comparisons on how different ways of viewing that building can actually engage citizens to provide feedback. So stakeholder feedback, we're working with the architect as well, hoping that some of the ideas that we collect from people who are future stakeholders will make their way into the design for the building. We have the iPad, which people can have a look at afterwards, where you can go in and do 360 views of the building as if you were in it, and tap and provide feedback about the building across the 7 petals of living building, which would be a whole other presentation. But I'm happy to talk to you all about it afterwards. We also created an augmented reality viewer. That won't work here, but if you're on the site, you can literally walk through the building, right? So it will move with you. You can look around and see the building. It's a parking lot now. It's a little hard to see the 2nd floor unless you can jump really high, but pretty neat. And then this is the full immersion virtual reality version, which we also brought along if people are interested in walking through it using the Oculus Rift full immersion headsets.
In terms of the other focus area, which is city operational efficiency, our efforts are mainly at the scope of Georgia Tech campus right now. We hope to expand that to the city, but for now we're looking at over 100 buildings on Georgia Tech campus, and that is also modeled in a virtual, in the same virtual environment. But the difference is we've brought the energy consumption data and utilities data into the environment, and they're color-coded and they can be visualized over time. The changes can be perceived over time. So on the left you could see the PhD student who is working on this research, who is interacting, and on the left is actually the associate director of the utilities of Georgia Tech. They're interacting with the buildings and seeing which building is doing, how they're doing in terms of consumption comparison to the other buildings. So the green ones are relatively good energy consumer buildings, and the red ones, the darker ones, the red ones are consuming much more energy. And there's a slider bar that they could move around time and see how that energy consumption relatively changes, and they can walk around the buildings and observe and come up with solutions and strategies.
And then the final pillar, public and business engagement, we're doing a project related to the North Avenue Smart Corridor. And so what we're doing there is, so we're very interested in engaging with citizens. So created an application, a mobile phone-based application that includes those pillars. So a citizen walking up and down the street can actually, if they see something that's going really well, or maybe not going so well, they can take their phone out. If they have the app, they can say, in terms of public safety, so I click the public safety button, I take a photo of what I'm seeing. You don't have to take a photo, and then type in what is your comment. Then we can take that data and we can look at it. I think it's because we're pretty far away. We can look at it in our laboratory. People come into our lab and they say, why do you have everything pushed up against the wall? Well, if you put on a HoloLens set of glasses, we can use the floor as a viewing area. And so we can project the city on the floor, walk through and see. Of course, we still do computational analytics, but what are the kinds of visual analytics, things that you can see that maybe you don't see when you just put it into a statistical package. So here someone's looking at the North Avenue corridor and looking at the data. We aren't doing this yet, but this is what we're going to do once we collect that data from that application. So those are how our research ties to the SMART objectives, Smart Atlanta objectives. The last thing, and this is just a slide, but we wanted to talk about how the Smart Atlanta strategies tie with where we see ourselves heading in research, because we'd really like to collaborate with the city. On the city website, it talks about the work that you're doing being descriptive, diagnostic, predictive, and prescriptive, where smart cities are concerned. We have, as you've hopefully heard throughout this presentation, developed a virtual version of the city of Atlanta. And so we think the necessary first step before those 4 or 5 steps is to create a duplicate, to create a virtual version of the city so that that data can be spatially referenced in that model. We're doing that through something we call Duplicity, duplicating the city. We create a smart city digital twin, created. And what we do, this is, it's hard to tell the difference. This is the real city is informing the virtual model. which then in turn cycles through, right? So we take what we've learned, apply it to the city, which then informs the virtual model and so on. The next area of work for us is really urban cognition, what we're calling cognicity, cognition in the city. So with all devices being able to talk to each other, with all of that data, how can we use machine learning techniques and other types of techniques to have the city really become smart and capture citizen input along the way as well? So we see this as fitting very nicely with the descriptive, diagnostic, and predictive strategies of the city. And then the third area, if we think about that application that we just are starting on with the National Science Foundation funding to identify these spots of emergency, the furthest reach out we would call an adaptive city. So that is a bit of predictive, a bit of prescriptive, but also how can the city itself, infrastructure systems adapt? And so like taking as an example a tall building fire, how can the building itself help to begin the evacuation process before the firemen arrive at the scene? So may sound a bit like science fiction, but these ideas, I don't know if you've got a close look at these, but they exist. The person who's having their house automatically cleaned looks very much like a Roomba. I wasn't paid an advertisement fee for that. On the bottom right, you see firefighters flying. Well, we aren't exactly flying yet, but we are using drones to improve the efficiency of firefighting operations. We aren't grinding up books and putting them into students' heads at Georgia Tech just yet. But you may or may not have heard of Jill Watson, who's a TA. She's actually an artificial intelligence, so it's not a human, who's helping students with a class. I think the first semester she got so-so evaluation results, but in the next semester she was up for a TA award, I heard President Peterson say. And then this last area I thought, well, that's not going to happen, aerocabs. But just this week in Dubai, the very first drone taxi took its first customer. So these things do, with collaboration, happen. And so we would like to collaborate with the city. The areas where we see the biggest opportunity for collaboration, data exchange, we've got the duplicated city, so we'd like to populate that with data. Infrastructure management, the things we're learning can be used to make long-term infrastructure management decisions, but we think the real opportunity is how do we make more real-time or near real-time decisions with this data. Citizen engagement, most of our applications you see have a citizen engagement component, which is maybe a little bit unique to the way we approach research, so we'd be happy to collaborate on those, share the smart North Avenue corridor data we're collecting. And then lastly, outreach. We're having a meeting next week with a K-12 program to talk about and envision the future Atlanta city competition, because we've wholly adopted the Asimov view of envisioning future cities. And so it'd be great to partner with the city on that, right? Get kids thinking about how the city could be different in the future. And then in terms of public outreach, this is us at the Ponce City Market Experience Smart Atlanta a couple of weeks ago, which was also, I believe, iPad helped, are the reason that we were there. And so I guess some of that collaboration is already happening. If you're interested in the various collaboration aspects that we mentioned, please get our email addresses and names and get in touch with us, because we're very happy to collaborate.
I'm just going to have this in the back at the end. Whoever is interested, you can look at it and have a look at our app. But also, if you don't have time to stay longer, you're always welcome to come to our lab at Georgia Tech, contact us, and we will arrange a visit. And there are very interesting things you will enjoy to visit.
Thank you. Do we do questions now? Questions now or later?
You were saying that you were able to see if people were upset or not. I assume that the source of your data was social media, maybe?
Yes.
In that order of ideas, I wonder if you guys have in mind, I mean, it's amazing, it's a really good tool, but at the same time, I can see some kind of problem of people that don't have access to those technology, like for instance in the area. So, so how do you deal with the equity aspect to be sure that the rich people with access to those tools were able to complain about the people, in the southeast of Atlanta, the elder and things like that they don't have that technology, were able to get
It's a great question. We are, we're collecting the data from the social media outlets, right? So they don't have to download our app in order to have access to this, but there's certainly people that don't have access to cell phones. We don't view this as replacing, but rather just an additional thing that can be used to identify issues. In Harvey, the 911 lines were jammed, people couldn't get through. And so people started, for the first time, we read, I don't know if that's true, but that's what it said in the New York Times or the Wall Street Journal, people were actually posting their address, like, please come save me. And so when 911 breaks down, then it's another channel. It's not a great answer, but one answer is if some people start using this alternate means that might open up more lines on 911.
And the question was for you, in these virtual environments that they were meeting here in Atlanta and talking about how analyzing the envelope of the building and the kind of thing. Is there something, the virtual world that you are creating is owned by Georgia, or you are using apps, commercial apps like Second Life?
No, we have developed that in our lab over the years. So it's not commercially available, it's our own, but
so it does mean that when you guys are saying that we can use those tools, that means that we can use those environment, virtual environment tools for meetings and things like that with Georgia Tech?
Oh, for sure, for meetings, yeah. Yeah, we have that class, we do global lectures. So rather than me tell them about a paper that was written by this gentleman, this professor in India, I just invite him to come and speak directly.
But again, it's not second nature. It's no commercial virtual worlds. It's the world that you guys created.
Yes. Thank you.
So,
Okay, I'm going to try and speak up if the air comes on. You might have to remind me. So my name is Amanda Ming, and I work with Carl DeSalvo and Ellen Zagura, as well as a computer science master's student named Tom Nguyen. And I don't know if you all remember, but so this little sheet here, it has all the speakers that have been talking to y'all. And we are all grantees of IPAT's Smart and Connected Communities data pilot. So when we saw this call for a data pilot project for smart and connected communities, our reaction was we already know about some already smart and kind of connected community groups that have been collaborating with academics as well as government agencies to do their own data collection. And that data, we don't know where it lives, and we want to put it in an open repository. And we also want to see how we can help facilitate those data projects, those research projects, because we've noticed that community groups, particularly over on the west side where we're working, they have a lot of inquiries, a lot of research projects they want to do, and we're very interested in supporting that. So yeah, I'm going to talk to you all about this project, this data pilot of building a local environmental data repository. We broke it down into 3 steps, so I'm going to go through those. The first step was to try and get a catalog, a survey of all of the data projects, the research projects that had happened in the past few years, because there's been a lot over, decades. But over the past few years, what data collection has happened? Where is that data? Let's talk to those data collectors and see if we can put it on an open portal. And so that process, we went to a lot of community groups, meetings, and just made a general call. We've also been working over there for a couple of years, so we had an idea about Emory's mold study and the Fish and Wildlife Service doing a Proctor Creek wildlife survey. So that's what you're seeing right here. So this is an example of the Fish and Wildlife Service partnering with the Proctor Creek Stewardship Council to go to certain sites along Proctor Creek and see what kind of wildlife was there so that they could get an idea of how healthy the stream is based on the wildlife that's present. So when I talked to Tamara from Fish and Wildlife, who is also a Georgia Tech grad, she said, yeah, we have this data set. This is what it looked like. As you can tell, this isn't, or maybe you can't, but this isn't machine readable data. So also it's set on her computer. So it wasn't open to the public. And they have these, you can see the site was Grove Park. Here's another site, James Jackson, Lindsay Street. And they have the name of the organism, how many there were approximately. So this isn't the kind of data set we would want to put online for other researchers to download and maybe add in with another kind of data set and do some analysis of Proctor Creek. So what we did is turn it into something machine readable. So it took some time understanding the data set, reprocessing it, and now we went through this process with around 14 data sets, and they're all online on civicdata.lmc.govtech.edu. And so this is an example of what that portal looks like. So you have the list of data sets, a short description, metadata information, and then a preview of what it looks like, and you can download it in several different formats depending on if it's mappable or not. So if it's mappable, we have shapefile, we have CSVs, that sort of thing. So this was step one, like what kind of existing data is out there that's in a closed space, and we can put it up on an online portal for researchers or anyone to use and play around with. Okay, so step two was we knew, like I said, there were organizations that are already collecting data, and we wanted to see how we could support that. And we began seeing these residents as research professionals in their community. And as professionals, we used some of this grant money to give stipends to residents to do data collection. This particular project is on the built environment, so a little different step away from maybe the Proctor Creek. But they were doing a catalog of the parcels on Brawley Street, which cuts through English Avenue and Vine City, north-south. And they were going and taking a picture of each parcel, what was the structure on that parcel, and categorizing it as occupied, dilapidated, vacant, good condition, that sort of thing, using the typical standard for a built environment survey. So what we did was we partnered with a lab at Georgia Tech called RNOC, and I can't remember what it stands for. Okay, so they have these tablets that they weren't using, and what we did is we made sure the mapping app and the map was on it, and they could use it offline to walk this street without needing Wi-Fi and collect data on the built environment for their own kind of purpose. But then, so they would go and collect this data, and then we would sit with them and process this data, make sure it had all the information that it needed, and then they told us, so what we want to do with this is match it to Fulton County tax data. So that was when our computer science student went and joined that data using some more sophisticated techniques. Beforehand, they had been searching each street address, getting the parcel ID, and going on to the Fulton County tax portal and one by one pulling off that information. So we went around the back end and took that data and then just joined it based on a matching unique identifier. So that was step two. Step three, you've already kind of seen that, is to format and store the data for reuse and making it readily available. So we're still, when we did this process, we sent our metadata and our description back to the data collectors just to make sure, are we getting this right? So it's kind of a bit of a process of working with them. But yeah, so we're still updating that data set. For example, the Proctor Creek wildlife data set that I talked about, they just did another data collection over this summer. So now we have a time series data to look at what wildlife was there last summer and now this past summer. Oops. So, okay. Oh yeah, so you can also see, this is just another quick example of one of the data sets, the Proctor Creek Stewardship Council. They were working with the Army Corps of Engineers to get an idea of what the community's concerns are. And the Army Corps wanted them to help them out in doing that survey because residents are better at doing that. I think we would all agree. And what we did with this process was turn paper surveys that folks went out and collected into a digital format and into this spreadsheet. And we also helped them do a report on it for the group as well as for the Army Corps. Okay, so some insights. It takes a lot of time and effort to really get, because I'm kind of an an open data evangelist, and I believe in open data, usable data. So it mattered to me that the metadata was good and correct, that the description was good and correct. So it takes time to understand from the data collectors. It's a little time intensive. I know the city doesn't really maybe want to hear about something being super time intensive, but understanding what the data is. We also have this anecdotal evidence that when folks are involved in data collection, they become data literate, which kind of makes sense, right? But data literacy, I think we can all agree, is increasingly more and more important. We live in this datafied world, and to be able to understand data, whether it's a visualization or raw data, is important. And so we think that when you're actively collecting it yourself, you're becoming more data literate. So if we can support, young folks, adults, we work with a range of ages in doing data collection, then that can help them become more data literate, and they can participate more in these data discussions that we're having. We also find that communities really do want to collect data and use it to enhance their legitimacy as local experts with policymakers. So we mentioned the Army Corps. The built environment has to do with the discussion of affordable housing on the west side, and the desire to have a community land trust as one tool of getting to affordable housing. And finally, required skills for building a data portal. You really got to be able to explain what this open data thing is, get other folks to drink the Kool-Aid, do some data wrangling, mapping, engagement with data collectors, and writing the metadata, and the website development. I hope y'all visit that portal, and maybe we can get it out to you, the link, because it's really quite beautiful. And Tom, the master's student I mentioned, did a really lovely job with it. So yeah, that's it. Are there any questions? I don't know, I have another slide. Well, there it is. So you can see the link right there in my email address. Questions? All right. Well, thank you.
I have a question.
Sure.
I was waiting. I don't want to dominate. I noticed Carl's name up there. We've been working with Carl on some research projects in terms of outreach.
Yeah.
Very related.
Mm-hmm.
How does this dovetail into that piece? Is it like a subset of the whole kind of broader outreach research, or is it separate?
Well, to be perfectly honest, one of the workshops on that smart corridor was done on the west side, and we could only be successful in holding that workshop because we've been doing this kind of work. So when we talk about a smart city and this use of data, because there's already this practice of collecting data, of having data conversations, and our support of that, then it makes us more able to engage with them on this smart city conversation. So it was more like we had the social capital to have those civic engagement stuff, and also recognizing and saying, you're already a smart community. Could you give us some valuable kind of feedback on how this is useful to you? I think is a really powerful part of how they connect.
So was it the same audience of people that you'd already built a relationship with that you then did the outreach research on?
The audience for the workshop? No, but our work with the data collectors, they helped us get more of a broader audience in the neighborhood, and because they kind of knew the value of data, I think they were like, okay, yeah, we'll help get other folks to this workshop, because we do think this is an important conversation of being a part of Atlanta's smart city. So.
Great.
Yeah.
I guess that question is very relevant, because one of the complaints that we are receiving specifically in the Puerto Creek area is that there is a lot of inquiry burden, that they are
Yes.
receiving multiple questions and multiple researchers. And you ask me again, what you ask me again.
Right.
So collaboration is fundamental.
There's some research fatigue over there, but I'll say every time I show up to a meeting, they're like, can you help us get this data and then present it in this way? So there's still a lot of inquiries that they have, and we try to accompany them in that. But I do know exactly what you mean. So it is. we're trying to meet them where they are with their data needs and research interests.
Well, it's very interesting because it's the intersection of two really key drivers for us, which is the open data piece. We're in the process of building out an enterprise data platform, and we have an agreement with Georgia Tech now, so that as we start collecting more data, and Georgia Tech, anywhere in any of their departments, would benefit from having that data, we have a means whereby we can share either large volumes of data or real-time data over to Georgia Tech so that they can get better research, better outcomes. The other piece is we've got a big heavy push on the outreach piece, which is helping to figure out what is the right thing to do around smart city when it comes to the population that lives here and calls Atlanta home. So very interesting.
Thank you.
Thank you very much.
Thank you.